Hey guys, welcome to this topics video where I took this SBAC question that's asking about transformations of parent functions. Something that I was kind of excited to see because this is what I'm teaching right now in my integrated math 2 class. But it asks the students to take this y equals x squared, or this parent squaring function, and drag it so that it maps out this function x minus 4 quantity squared plus 2, right? So this minus 4, if we know our parameters of transformations, this minus 4 is going to take this graph and move it 4 units to the right. And then the plus 2 is going to move the graph up 2. So they should have a parabola. Drag the parabola so that it's up here, right? So I want to show you, I attached a couple GeoGebra apps in this topics, or this week's topic. Mess around with those if you want to, but I'm also going to show you how I made one without trying to make this video too long. But here are those apps that I've made right in this neck of transforming parent functions. So what this one does, and I need to change the title because we added cubic to it, my student teacher and myself. But this allows us to choose 1 out of 5 different kind of parent functions. So they can do linear, they can do quadratic, which I'm calling the squaring function also, absolute value functions, exponential, where you can choose your base. So if I were to say choose exponential, it's pretty neat because I can change my base to be whatever I wanted it to be. And we're only looking at positive bases right now. We could definitely change our slider up, get a negative base, and explain what those graphs look like and why they look like that. And also we have a cubic, or a cubing function, right? So here's our parameters. A, which is our stretching parameter, takes a parent function and just stretches it, right? H is our horizontal translator, so we can move the graph horizontally if we wanted to. Okay, and then K also is our vertical translator, so we can move the graph up and down, right? Also, if you didn't want to slide, sliding just allows, people to kind of explore what the variable is going to do to a graph. If they knew, like an expression that they're trying to graph, they could just set their parameters to be whatever they want to. So maybe we know we want the graph to translate maybe 3 units to the left. So if I do that, it'll move the graph for us. So this app is really neat as far as choosing different kind of functions. Maybe they want to do a quadratic. I like how it keeps a dotted parent function as far as a guide and talking about where the function is transforming from, right? So this app does a very good job as far as an exploration kind of way, or matching expressions or graphing expressions. The second app that I have here, which I'm just going to right click and go to my standard view, is this app where I wanted my students to kind of get a little process of graphing transform functions. So the first thing that I have them do is, well, first pick their parent function of what they want to graph. Maybe they want absolute value, so I can just put in ABS, which is computer talk for absolute value. So ABS parentheses x, so absolute value of x. If I hit enter, there's our parent function. And then we can go ahead and graph by, I want them to think about their order of operations, keeping the same order when we transform. Do your horizontal translation first, right? So slide it horizontally first, then do the shrink it or flip it or stretch it, however we decide to describe that transformation. And then also the last thing we can do is vertically, which I just realized I spelled vertically wrong. So I'm just going to fix that. So whenever you want to change text, you can just double click it and fix it. So translate vertically if we want to. The nice thing too is we can clear our parameters, so we can get it right back to the parent function. So here is our general function, f of x equals absolute value of x. Or maybe, we want to look at a cubic function. So x raised to the third power, there's our cubic. But one thing that I like about this app is as we move a variable, we get its expression to pop up. So students can start relating, oh, that h, when we look at that general form of our transformation of any parent function, we can start making generalizations. Oh, h is going to move horizontally, and then when we move a around, we'll see that expression. Oh, that's stretching, right? And then the k is our vertical move. So as kids are playing around with this, they can see their expressions change, right? So now we have a new expression when we have a, and then we can add our last expression if we have a k value. So even if a is 0, or 1, excuse me, then that expression's gone because we don't need that 1 in there. But because I have a k, now here is our expression that we're graphing. So connecting variables to what it does to the graph and also the expression is the point of this second GeoGebra app. And this is the one that I'm going to show you how to make. Okay, so I'm just going to go File, New, and we're going to have a complete blank screen here. All right, so it's a graphing app, so I want to have my coordinate grids and my axes up. So what we need to be able to do is we're building this basic idea here. What we're going to do for the app is let the kids, or the students, or yourself, if you're demoing this, let them pick what function that they want to graph. Let them choose the parent function. So for this problem, they would choose the x squared, which is part of the math, problem. And when you look at a transformed function, what was the parent, right? Where did it transform from? So we want them to pick the parent function, and then we can then just throw some text in there and have them move some sliders around this a, h, and k and watch what it does to the graph, right? As far as the text goes in hiding, that took some conditional logic, which I probably will keep out of this video. If you do, or if you are curious about how I did that, please email me or post a comment on this website and let me know, and then I'll go further and all that stuff. So in our blank screen here, let's first of all, we need to create our sliders. So I'm going to grab my slider tool, and just over here for now, I'm going to let A, which is my stretching slider, I'm just going to choose -10 to 10. Increments, maybe they want to jump up by a half, 0.1, a quarter, whatever you want, or by 1. Maybe I'll just go a half, and I'm going to click Apply. Now let's make a second slider. I'm going to call this one H. This will be our horizontal translating parameter. And we'll let them translate 20 units to the left, 20 units to the right. Call it a half of a jump. And then the last one, K, is our vertical translator parameter. And same deal. We can go 20 units down, maybe 20 units up, and jump by a half. And you can set that to whatever you want. Okay, so now we have the parameters set here. So what I'm going to do in my input bar to make a general statement like this, I'm going to create, first of all, an f function. I'm going to define f of x just to be something for right now. That way GeoGebra knows that there's an f function. Maybe we'll call it x squared because that's what we're looking at right here. Okay, so in my GeoGebra, in my input down here, I'm just going to type, and you don't even need to put the f of x. You can if you want to. But even if you just put an expression like x squared, for example, GeoGebra will just by default create a function. Okay? Maybe I want to center this. By the way, a little pointer, if you want to move your graphics view, you can definitely use that tool. Also, if you have any other tool selected and you want to move your graph around, hold Control down on your keyboard and you can change your graphics with any tool you have selected. So it's kind of a nice little shortcut. Okay, so we have some function f defined. We have our parameters defined. So our next function then, maybe g of x or whatever we want to call it, or let GeoGebra default it doesn't really matter, is we're going to have a, since GeoGebra knows what a is now, we're going to have a times f of x minus h plus k. And so when I hit enter, now I have my transform function. It's defined by what a, h, and k are, so as I move a around, it's going to go ahead and change our transformed function. We can translate it any way we want to. We can flip it upside down and translate, so we can do whatever we want to our parent function. So now let's put the feature of letting the students pick their parent function. So now what I'm going to do is go to my slider tool box, but I'm going to grab the input box. I'm going to click somewhere on the right, and you can always move your sliders and your text boxes and input boxes around. So what do we want to call this? I'm going to just say f of x equals, and that's what they're going to see. And then we're going to link this text to our f of x function. So I just hit this little arrow here, and now I'm going to link this to my f of x. So I'm going to click apply, and now we have this little default input box here. Again, if you don't like the default choices, which I don't, I think it's kind of boring, you can make the size a little bigger if you wanted to. You can change the color of your text if you wanted to. If you right click your text box or input box and go to the object properties, we can change this gray color. You can also change that if you wanted to. So we can go to color here, and notice we have foreground, which is the red. The background, maybe we wanted it a different kind of blue. I guess we can't change the gray, we can just change the box. If you go over to style, it tells you the box length. I usually make mine about 6. Just seems to be a size that I like. You can go less if you wanted to. But here is our text box that'll take in any function. So now, because we defined g of x, our second function, to be defined by these parameters, and we're applying those parameters to f of x, now when we change f of x, it's going to also change our g of x. So what we have now is the ability to change our function to anything we want to, maybe 2 to the x. And now we can also transform them. So then the last thing that we can do then is grab our text box, and this is where we can say graph the transformed function. Something like that, right? So maybe I have some text box there. Again, you can change the size, the color, all that stuff. Now here's one thing too. Let's say that we want to keep, I'm going to keep this, end this video here, and it's just a customization job from here. Okay, but graph the transformed function. Let's say that we like it the way that it is right there. But when students are zooming in and out, notice what happens to the text. It moves around on us, and we may or may not want that to happen. I hate when that happens on my own apps, so I always want my my text box to stay where I put them. Sliders and input boxes, like you see on the right side over here, they'll stay. They by default will be they'll stay where they're supposed to be, known as their absolute position. So with text boxes, to keep that from happening, all you need to do is highlight your text box. This little pin up here is absolute position on screen. So if you just click that, then when we zoom in and out, oops, if we zoom in and out, that text should, oh, it didn't work. So let me try this again. I'm going to click there and click that box. Yep, it should be good now. So if we zoom in and out, now notice that text box, the text stays where we want it to. So that's always a nice feature too, keeping your stuff where you want it to stay. If you wanted to keep it fixed so that students couldn't change the values or anybody could change the values, you could always right click a text box, true with anything else. Right click, go to its properties, and you can fix the object. Okay, if you click fixed, then you can't double click and change anything. It'll just say what it is and nobody can change it. So anyways, that's kind of the skeleton basically of this transformation app. I just did some different colors, moved my sliders so that students can look over here. Oh, and the clear transformation parameters. This is kind of nice because if we want to start over, we just clear it and we get right back to our parent function, and notice our translating values are now 0 and our stretching values back to +1. And the way that we do that is I'm just going to go to my slider toolbox or where the input box is, and we have an OK button or just a button tool. So put a button in here. We can say what we want on it. Maybe we want to say clear parameters. So now the script is a little bit of code, and you do have to kind of know a little code. I've researched. It's super easy just to Google GeoGebra Plus and then any kind of code that you want to do, and there's some awesome resources on that. And again, if you want to know more code or more how do I do this, please feel free to email me or put a comment on the site. So the way that we can do this is there's a function called set value. So if I type set value and I'm going to use square brackets, I'm going to set a comma to 1, and I believe that's how that's going to work. So I'm going to click apply here. So I only put a in here for right now, but if I click clear parameters, let's watch a here. Right now a is at negative 2.5. So if I hit that button, notice now a, oops, I have my tool selected. A went to 1. So we're good there. Now I want to add h and k in there. So I'm going to go back to my object properties. I'm going to go over here to scripting, and then it's the on click. When we click the button, we want some stuff to happen. So there's my set value of a, and then I just do the same thing for my h, which I don't want it to be 1, I want it to be 0. We don't want to translate anywhere. And then also set value of k, comma, set it to 0. And now when I hit OK and get out of that window, now when I hit clear parameters, everything is going to adjust. We're back to our parent function, and then we can do some more transforming and all that good stuff. Alrighty? So I hope that made sense to you guys. And again, if you have any questions or comments, please feel free to let me know. Thank you.